Hello, my name is Zhang. I'm Senior Solution Architect at AWS Energy and Utilities. I'm also the chair of IEEE's Task Force Cloud for Power Grid. In this video, I'm going to show you how to use AWS to create an HPC cluster to run power system simulations in parallel and cost effectively. First, let's go to visit our project repo page on GitHub. And if we enter this tutorials page, and go to that first folder, open the cluster setup text file, you can find this detailed instructions about how to create the HPC cluster step by step. As a prerequisite, you need to have the AWS Parallel Cluster tool installed. You literally just need to follow that user guide on the AWS documentation, which will help you to will guide you through the installation and the configuration of the AWS Parallel Cluster tool. You can either do this on a local machine or a virtual machine in the cloud. In this demo, I'm using a T2 micro instance on EC2 as a dedicated host for the cluster creation. So you can see I'm using my key to log on to this virtual machine and use the source command to activate the virtual environment for the parallel cluster, which has the Python the required libraries configured. And next step is to use the create cluster command to issue a request of the cluster creation. This command takes two mandatory arguments. One is the cluster name, which you can specify whatever name you want. Another is a cluster configuration, and provided in a YAML file. And you can find this YAML file on our project repo as well. So once I hit enter to type into this command, it will take up to 15 minutes for the cluster to be created. So let me pause my video here and we will come back when the cluster is created. Okay, now the cluster has been created, and you can verify this on CloudFormation because AWS Parallel Cluster leverage CloudFormation behind the scene to launch the resources for the cluster on behalf of you. And you can see the events in a chronological order and also the created resources through the CloudFormation stack information page. Now, let's go to the EC2 console and find the instance named head node. And you can just copy that public IP address of this instance and paste it into your browser, or just simply close this hyperlink to open this cluster's homepage. And there are three buttons on the homepage, which will bring you to four different services in the backend. Promiscuous server collects the matrix for the EC2 instances, as well as the job scheduler's working information. Grafana dashboard is basically a mechanism to monitor the run status, which provides you an interactive web visualization. And run submission is a React UI-based page where you can submit the request to run a few different study cases. For example, if I select the IEEE 14 bus system to run, and you will read a message returned by the system specifying whether the run request has been successful or not. And then you can go to the run monitoring page, which is essentially the Grafana dashboard. And you can go to that parallel clusters summary page, which is one of the pre-created dashboard. And you can see now, currently there are 8 jobs pending. And in a few minutes, this job will finish. In the backend, if you go to the EC2 console, you can see several EC2 instances has been launched as a compute load of this cluster. So basically, it will give you the scalability of the cluster. No matter how many jobs are going to request to run, it will help you to meet the resources requirement. And once you have this results done, you can go to the run results page and view the run results data through the web page, or you can simply download them. That's about it. Thanks for watching.